Hello friends, welcome to Joy of Life. So today we are going to look at another medium level problem from Leetcode. The problem number is 138. So just a mention, as I have done this problem previously on this platform and we have done it with a different approach, but the problem statement remains the same. So what you can do is using the timeline bar, you can skip over to the dry run section and continue watching from there. But if you have not seen the earlier video, you can find the link in the description and you can continue watching the video without skipping so that you understand the problem in details, which will take a couple of minutes time. The name of the problem is copy list with random pointer. So it has a quite a long description. So let's check it. A linked list of length n is given such that each node contains an additional random pointer which could point to any node in the list or to null. Okay. Construct a deep copy of the list. The deep copy should consist of exactly n brand new nodes. Okay. Where each node has its value set to the value of its corresponding original node. Okay, got it. Okay. Both the next and the random pointer of the new node should point to the new nodes in the copied list such that the pointers in the original list and copied list represent the same list state. None of the pointers in the new list should point to nodes in the original list. For example, if there are two nodes x and y in the original list where x dot random points to y, then for the corresponding two nodes x and y, the copied list x dot random should point to y. Okay. Return the head of the copied linked list. The linked list is represented in the input output as a list of n nodes. Each node is represented as a pair of value random index where val equals to an integer representing node.val. Random index, the index of the node range from 0 to n minus 1 that the random pointer points to, or null if it does not point to any of the node. Your code will only be given the head of the original linked list. Okay, and they have given some example. So let's understand this example in little details. So here I have a value. So these are each nodes, right? These represent one node. So each of the node, like a linked list, has a value and it has the pointer to the next node. But it has a random pointer as well, which can point to any node in the linked list, including null and self as well. So as you see over here that in the first node points to a null, the second node's random point to the first node. So it might point anywhere. It has no fixed order. It can go anywhere. And so what do we need to do? We are supposed to do a deep copy of this linked list. We should be returning exactly a clone of this list, which is a deep clone. So deep clone means when I create this random should not go and point back to the original list. It should remain in the same list. So yeah, this is the problem all about. Do give it a try. There are different type of solution available for this kind of problem. Is a linear time solution, constant space solution, some naive solution. So do give it a try before you check out the solution that we discuss here. I plan to create multiple videos on this one, at least discussing two of the most optimal solution that I have in mind for this problem. So let's move over to the board and check out how the solution looks. Once again, I have taken the example, almost the same example. So we have the nodes 7, 12, 4, 5, 8, and there are three boxes. Each of the boxes represent one different thing. The first one represents the value, that is 7 that you see over here. The second one points to the random um, pointer. And the third one is the next pointer. As you see in all the nodes, it points to the next one, and the last one points to the null, right? So the example is pretty same as the last one. What I have done is I have introduced the null as well. So 8 points to null. Previously, it was pointing to some nodes over here, 7 or 12. I don't remember exactly, but almost overall, the problem statement is same, and the example that I have taken, the list is also the same. Okay, so the last solution that we have looked at contains a map wherein we have been storing our lookups, right? And it gave us an order of n in terms of both time and space. So this solution is going to be very close to that one. The only thing that we are going to improve over here is that we are not going to create a map, but we are trying to do it in a constant space. So we are going to leverage what's been given to us, and we are not going to create any new data structure to hold our values. So we are going to see how we can leverage that. So the basic intention remains the same. We have to create a new list and we have to make a deep copy and we have to return the head for that list. So we will start creating this new list node by node by going to the first linked list, and what we'll be doing over here is something very important for us to understand. So as you see in the first list that we have the nodes pointing to the next node, right? We are going to change that. We cannot touch the random pointer because it points to something that is irreversible, because if this mapping is damaged, I cannot do anything about it. So as I create the first node, I am going to manipulate things over here. So I am going to destroy this mapping that we have over here. So you can see that one is the first node of the old list is no more pointing to the next node. So what are we going to do? So in this new linked list that we have created, first we'll clone the value. So that is a very simple part. So we have two nodes, right, with two pointers starting with two hits, just the way we did it, right? And now what we are going to do is we are going to point the next node of of this node to this node, right? We'll see why. And subsequently, we are going to put that same thing back here again. And we will continue to do so for the next node as well, and for all the nodes. So at the end, we will have a list that looks like this. So this points to this points to this points to this points to this, and so on. And the last node doesn't point to null, it points to this. So what is essentially happened over here? So I know that the actual relationship that was present is still preserved, right? So if I have a node n in the old list, right, I used to know that n dot next point to the next node, right? Nothing has changed. I know now the relation has just changed to next dot next. The relation is still intact. So if I have to see the next node, I know that it is on next next, which is this 12's next next. So the relationship is still there, right? So this is on the first pass that we are going to do. We are going to break the current link and re-establish the link, including the new list. So it will look like this. So that is going to be our first pass. Now on the second pass, what will happen? So in this, so in the second pass, I know that I have to point. So what will happen over here? See how we easily we can establish the relationship of the random pointer now. So once the list is in this state, so I can make a jump from the first node's random pointer and come to this node, right? And I know this node's next node is the random node for this node's next node, right? A little complicated, just try to understand. So let's say this is denoted by A. What is A? What is A's next? A dot next. So any node pointed by A over here. So A dot next is nothing but A's clone, right? We are dealing with the node A, right? Keep that in mind. So next, what is going to happen? What is A dot random? A dot random is the node pointed by the random pointer in the node A, right? So A dot random dot next. What does it signify? Just see this relation, right? Is random's clone, right? Isn't it? Because I know every node that I point to is the clone node. So, so it is very simple. The original node followed by a clone node, then a original node, clone node, right? So when I go to A is random, I know the very next node is nothing but A is random's clone, right? So what I can say from here is that A is next. What does A next denotes to? A dot next denotes to this node dot random. What does this denote to? This denote to this cell over here, right? Is what? It is nothing but A dot random dot next. What is A? This is A. What is A is random? This. A is random next is this. So when I do the statement standing at A in this position, so what basically happens is the magic that we are looking for, right? That we establish this link, right? We have done this. Now moving on. So I move the pointer A to the next node, right? So how do I move? I should do a dot next dot next. So generally we do say we do n dot next. We'll be doing n dot next dot next. So A will now come to say this node over here, right? This node, right? So again, you see what I am doing is A is next dot random. So we are talking about this cell over here, right? And what are we assigning it to? A dot random, that is points to this node 8 over here. It's next. So this yellow node. So what will essentially happen is we are building this relationship. So we are not using any extra space. So we are just establishing this relationship, right? Same goes for 4. So again for 4 also you'll see the same magic happening. So A now comes here. So A is random points to itself. So he's next is he himself. So this will establish a relation like this only, right? So at the end, what will happen? Our random pointers are ready, right? But what is screwed up over here is the next pointer, right? But that's very easy to solve, right? I know that he's next is next dot next. He's next is also next dot next. So we are going to traverse once again and we are going to reset this back. We are going to cut these links one by one. We'll cut this and put here. We'll cut this and we'll put here. We'll cut this and we'll put here. Cut this and put here. And it will happen for all of the nodes that we have dealt with. So we'll basically cut all the links and we will end up with something that you are seeing on your screen at the moment, right? And you see for this last node also, who is its next dot next? Its next dot next is a null. So null will once again come and sit over here and this will get cut. And he's already pointing to null. We don't need to do anything for him. So you see now what will happen is we'll remove if we remove these lines, we'll have two separate lists and we have not used any extra space in order to do that, right? Just that we'll have an order of 3n uh, runtime complexity over here because we'll be traversing 3 times. But again, as you know that since this constant doesn't matter, which in turns means it's the order of n only. Okay, and we have not created any new mappings or storage or data structure we have used for the lookup. We have used whatever was given to us, we have made the best use of it. And so let's move over to the code and see how the solution looks. Let's say we create a node and name it ptr. Okay, and let it point to head because we need to preserve the head. And while ptr not equals to null, see this time we are not going to create a head unlike the first time because we are not creating a new list. We are appending to that list and getting things done over here, right? So we'll not be creating a new head like the fake head that we have created. Now we are going to create just a new node, and every time we'll be creating this new node with ptr.val, right? So this will create a new node and assign the same value. So we'll have the clone node with only the value. Now what we are going to do is we are going to take a temporary variable here because we are going to unlink the old list. But if we just unlink it, it's going to lose it, right? So we are going to put ptr next into it, then going to unlink it equals to this new node that we have created, right? And what we are going to do is now this link has been created, right? So this new node that we have created over here, so the next for the new node should point to whatever temp is holding, right? Because that's how you get that relationship. This points to him, he points back to him, right? One more thing we can do for efficiency over here is we can point the new nodes random to pt as random initially. This will make things easy for us, right? Because what we basically did over here is that initially we also pointed it to the node from this list itself. So just to make you understand again, so let's say I had 3 nodes over here, right? This is the first one, this is the second one, and the third one. So this next was pointing like this, and let's say this was the random pointer. This is pointing to null, and he's pointing to himself. And they had some values 1, 2, 3. So what I basically did is created a new node, right? Copied the value 1, pointed this guy here, pointed this guy here. This link is gone, and pointed him to this guy itself. Similarly, for the next node also, we did the same kind of thing. Destroyed this mapping, put this one, this is pointing to null. And again for the third node also, we are going to point to this one only. We'll not point to self, and this is pointing to null. And yeah, so this guy's next is again pointing here. So you got the point, right? Why we are doing that? We are just pointing it back there so that we have a mapping from there as well. Moving on, what we should do now is we should increment the PTR and we should take it to the new node. So two nodes jump we should do, right? So this iteration, how it's going to happen is from this node, we should not come to this node. We created, linked it, that's fine, but we have to go to this node. So this node is now denoted by temp. So that's what we are doing, PTR equals to temp. So at the end of this loop, our mapping is fully established over here. So we are good with that mapping. So let's reset the head back to the pointer. Let me get some space. Okay, so we are going to iterate again, and we are going to iterate until this is not null. So we have started all over again, the iteration, and we are going to get the clone node now. So clone node is nothing but ptr.next. That is the clone node, ptr's clone node, and let's create another node and let's call it temp. Clone node. What is this clone node? So basically, if this is the node, this is my clone node. So if this is ptr, so this is ptr next. That's what we did, ptr.next. So what is clone node dot next? Clone node dot next is this one. So this is just our pointer that we are holding so that we have to traverse also in future, right? That's the only use for this. So clone node, what I'm going to do is now I have to set the random for this clone node, and we are going to use the same formula that we have done over here. So first one check we have to do in order to do that. So if the random is equals to null, in that case I know that it will be null only, right? Otherwise what we are going to do is otherwise we are going to do the part that we did. So we are going to go to the clone node, this one. So clone node dot random dot next. So if you remember, that's why we have put the new node, we have copied the random pointer so that we can use that same node's value and find out what is going to be my random pointer, right? So what will happen after this statement is, so PTR we have to increment at the end, so we'll put PTR equals to temp. So what will happen is PTR will come to, so what will happen is PTR will come to this, right? So initially what we said, we said clone nodes next. Clone nodes next was this only. So PTR will be here first, then it will come here. So at the end we have established all the mapping, but we now have to remove all these crosses and re-establish the two list, right? Now what we have done has completely merged the two list. Node, clone node, node, clone node, node, clone node, like that. Now we have to get rid of that and make the two lists separate so that we can return our uh, intended list. So for that, we are going to iterate once again. As usual, we are going to reset the PTR back to head. And now what we need is a new head that will be returning back, right? And we'll start iterating. So again, we'll go to the clone node, and clone node is nothing but ptr.next, right? This is my clone node, node, clone node, node, clone node. So we started with the node, so the next node is the clone node, right? And we are going to also keep a track of the clone nodes next because we need to iterate as well, right? Okay, so now what I'm going to do is if new head is null, so initially it will be null, right? So I'll be just doing a check. If it is null, then I am going to set this new head to my clone node. So this statement is going to uh, be true for the first time only, and it will set my new head to the first node, very first node, and that is what we need to return at the end as well. So let's put the return statement, new head, okay, right? And clone node dot next is equals to ptr dot next. Now clone nodes next should be ptr next dot ptr next, right? But there is a possibility that ptr next itself is null, right? So what we'll do is we'll put a null check into place. If it is null, then we'll put the null back. Otherwise, we are going to do a ptr's next, or we are going to now at the end we are going to reset the ptr to temp so that the iteration continues. Okay. So yeah, that is all about it. So let's do a submit and check. So yeah, it has been accepted, and let's do a submit and check for a broader range of test cases. Yep, cool. It has been accepted as you can see over here, and the solution is pretty simple, but it's a little complicated. We have to play with a lot of pointers here and there, right? So as you can see over here, that we have been doing a lot of pointer manipulations over here, but at the end we are leveraging what was given to us, and we can come up with a solution wherein we are not using any spaces, right? So I hope you got the solution. The intent was once again to give you the insights on the solution, and I hope I was able to convey the idea in a very simple way to you guys. So do let me know what you think of it. And so before we conclude this video, we are going to have a small check. So as you can see here that for our runtime, there has been no improvement, right? Because it's still a order of n. So you can see over here, this is our last solution that we did using using that map solution. So here also our runtime was 0 milliseconds. So you can easily understand that order of 2n and order of 3n does not make any sense. They are constant at the end. So what we see a drastic change is the memory usage part. We had a 39.2 MB, which is less than 9.52 of all the submissions right over here. But with this approach, you can see that our memory usage has improved over here, right? And we are now better than 86% of the submission. So you can see from 9.52% to 86.43% is a huge jump, right? So how it will matter is when we have a test cases that containing maybe thousands or millions of nodes over here, then this difference is going to increase with the time, right? You'll have the bigger and bigger the difference will become, and that will start making an impact. So what happens basically is in BIGO or for the space complexity, what we tend to check is the tail behavior. So as the input grows, what we tend to see is the time and the space. So when we have maybe 1 million nodes or say 10 billion nodes like that, so you see that with a small number of test cases also, the difference is about uh, close to 1 MB, right? When it goes to a billions of nodes and a huge data set, what will eventually happen is this gap will start increasing to a great extent. So here we will on the other solution, what we'll end up doing is having 1 billion records in a map, which is not that efficient. We can do that. It's not that we shouldn't, but ideal way is to use as less memory as we can, right? And to come up with the optimal solution, right? So I hope this video was able to give you some idea on how we can approach such problems. Though I don't recommend this kind of solution to be given during an interview, could be very tricky. There is a high possibility that we can, so interviews are very stress time, right? When you're trying to solve a problem within a certain period of time, maybe 30 to 45 minutes. And when you are playing with so many pointers here and there, changing the links here and there is a possibility that you miss out on something. And if that mistake is caught by the interviewer and you are unable to identify where you did something wrong, so let's say from clone.next we maybe wrote ptr.next. So at the fag end of the at the fag end of the interview, the interviewer says, I see some mistake. And at the time, it's very hard for you to identify the problem. Though you have given the algorithm, you have talked about the solution, it's going to make a very good impression. You have given the most optimal solution in terms of both time and space. But finding that small mistake that you did, maybe in the pressure of interview, it's very hard for you yourself to identify that kind of fixes. So I will recommend that try to keep the solution simple during an interview. So as we see over here, this is also a linear solution, and we are not doing so much of pointer here and there. We are not flying kites over here, that the strings over here and there, the way we did, especially over here. This kind of solution is a good candidate for an interview. But yeah, this kind of solution is also good to know. And if you during an interview, if you come up with the solution and at the end you save some time and you talk about this a solution with a constant space is also possible. If you give this insights and tell him the algorithm without the code also, you're going to make a huge difference in the interview, and it's really going to be something very impressive. I'll leave it up to you which solution you like more, and which one you want to uh, take up during an interview if you are faced with a situation like this. But yeah, I have my recommendation in place. Do let me know what you think about my thoughts. I should go for such a complicated solution or not. So to be honest, there is no right or a wrong answer, right? You can go for either. I'm just proposing you something, but it's not that you have to go for the one I said, but it's just a personal choice of mine. So yeah, once again, I hope you like the video. Do let me know in the comments. Do share, subscribe, and like, and help the channel grow. It's almost 150 subscriber. It feels really great, and it keeps me motivated as well. And I hope to create more videos in the days to come. And once again, if you want me to solve any particular problem from any platforms, or if you have any problems offline, do let me know. It will be I'll feel good if I can assist you and to come up with a video like this wherein it explain everything in details. I try to keep it as simple as possible, both in terms of explanation as well as code. So do let me know. And yeah, I'll end this. I think I've given a lot of lecture at the end of this video, but I hope it makes sense as well. So until then, see you guys. Have a great day and a happy Sunday. Bye bye.